In this particular question, we've been given a rectangle which is to be inscribed under the function y equals negative x squared plus 4. We need to find the dimensions of this rectangle if we wish to maximize the area of the rectangle. I've started by graphing my quadratic function, whose vertex is going to be at 0, 4, and it should have undergone a reflection in the x-axis, meaning that it is concave downwards. Using the green marker, I've inscribed a rectangle under that curve. This is one of many possible rectangles I could inscribe. I'm just using this one for the sake of illustration. Now what I've done is I've plotted a point P on the curve whose coordinates are x and y. You'll notice that the point P on the curve also represents the corner of, or one of the corners of the rectangle. I've also clearly labeled what x and y are in this case. So what you'll notice is that the length of my rectangle is going to be equal to 2x, and the width of my rectangle is going to be equal to y. Rather than using the variable y to represent the width, I could use negative x squared plus 4, because we know that we're dealing with the quadratic function y equals negative x squared plus 4. Now, if you remember, what we're trying to do is maximize the area. So we have to be dealing with the formula for the area of a rectangle, which is area equals length times width. This equation in its present form has three variables, a, l, and w. We'd like to be dealing with only two variables so that it's a function. So we can replace the length with 2x and the width with negative x squared plus 4, so we end up with area equals 2x times, in brackets, negative x squared plus 4. We expand that using our distributive property, and we get that a is equal to negative 2x cubed plus 8x. We take the derivative of that, a prime, and we end up with negative 6x squared plus 8. We now set that derivative equal to 0 and solve for x. We end up with x is approximately equal to 1.15. So I've got my value of x. Now I need to calculate my length. Well, my length is equal to 2 times x. So 2 times 1.15, which is approximately equal to 2.3. My width is equal to negative x squared plus 4. So I substitute in my value of x into that equation, and I find that my width is approximately equal to 2.68. The only thing I have to check now is, am I truly dealing with a maximum? So I take my second derivative, a double prime, which is equal to negative 12x, and I substitute in my value of x, which was 1.15, and I find that a double prime at x equals 1.15 is equal to negative 13.8. A double prime is less than 0. It's negative. Therefore, I do know that I am dealing with a maximum.